In the last problem set, we discovered that the coefficients of Pascal's triangle can be found using a formula, which is n factorial over r factorial n minus r factorial. And the binomial theorem spells that out for us. So, for example, remember the notation for this is nr. Okay, so the first coefficient can be written as n0. Second coefficient is n1. Third coefficient is n2. Do you see it's off by 1? The third coefficient has r equals 2. And the last coefficient is n, because there's always one more term than there is order of the equation. So for example, if it's a sixth order equation, there's 7 terms. If it's a 10th order equation, if it starts out with x to the 10th, there are 11 terms. Okay? So let's see how this works. Using the binomial theorem, we can kind of figure out what any term is going to look like without having to go through all of Pascal's triangle, okay, because we already have a formula to figure out what the coefficient is, okay, using factorials. Okay, so let's see. For number 1, let's do C, since it's a little bit more complicated. It asks us to find the first 3 and the last terms of these expansions, okay? Remember that the first 2 terms and the last 2 terms are kind of easy because remember in Pascal's triangle, the first term is coefficient is 1. The second term, the coefficient is just m. Now the third term is a little bit more difficult. So first thing you need to do is you need to identify what a and b are. A is equal to 2x, right? And b is equal to negative 3 over x. Okay, so basically this is a plus b to the 20th power. So the first 2 coefficients are going to be 1 and 20. And the last 2 coefficients are going to be 20 and 1. The third term, it asks us to find the first 3 terms. The third term is going to have the coefficient can be found using the formula 20, n equals 20, and r equals 2, remember, because this is r equals 0, r equals 1, r equals 2. Okay, 22. And then what about the a squared, or the a, b? This would be a to the 20th. This would be a to the 19th times b to the 1st. This would be a to the 18th times b to the 2nd. This would be a to the 1st times b to the 19th. And then this would be b to the 20th. Okay? And then you just substitute in a equals 2x and b equals negative 3x, and that'll give you the terms. Let's do this term because this is the only really challenging one. So first, n equals 20, r equals 2. How would we find this? Well, you can find it without the calculator using 20 factorial divided by 18 factorial, which is n minus r factorial, and 2 factorial. So this would give you 20 times 19 divided by 2, which is the same thing as 190. Okay? So we're going to erase all this now so we have more space to work. And we're going to write 190, which is this coefficient here, times a to the 18th, which would be 2x to the 18th. And then b squared would be negative 3x squared. Okay, and then it says do not simplify, so we don't have to simplify. Oh, and I made a mistake here. I wrote 2x to the 18th, but it's actually 2x to the 18th. Okay? The other terms are easier. Like the first term is a to the 20th. which is equal to 2x to the 20th, right? 2x to the 20th. And the second term would be 20 times 2x to the 19th, and then times b, which is negative 3 over x. Okay, so those are the first three terms. Number 2, without simplifying, write down the 10th term of, and then we have this binomial here. Okay, what are the a's and b's here? A is equal to x, b is equal to negative 2 over x. The 10th term, that would be, let's see, n equals 17, because it's a 17th degree equation. And then r would be 11, because they asked for the 10th term. So we look for r equals 11. So the way we would write that would be, using the binomial theorem, it would be 17, r equals 11, and then it would be a to the, let's see, 17 minus 11, which would be the 6th power, and then negative 2 over x, which is the b term, to the 11th power. And then 17 over 11, we could do that by hand, or we could do that with a calculator. I don't think they would ask you to do that without the calculator. The way you would do that with the calculator is you would do 17, and then you would do math, go to the PRB menu, go to NCR, and then you would type in 11 for R, and it would give you 12,376. And then, so we can put the result from the binomial coefficient equation here, 12,376, and then we'll just bring down the x to the 6 and 2 over x to the 11th. I just took the negative sign and put it out front because negative 1 to the 11th power is negative, so I just put it out front. I didn't simplify otherwise because it didn't ask me to. Okay. Now, number 3, consider the expansion of x plus b to the 7th. Write down the general term of the expansion. Okay, so when they ask for a general term, that means they're not asking about the first term, the second term, the third term. They're asking about some term, which we write like that. So we can write that out here. Okay, do we know any of these numbers? Well, we do know that n is 7, right? And we do know that a is x, b is just b. Okay, so n is equal to 7. So we can fill in all the n's. R we don't know because they said it's the general term. Okay, and then it says, find b given that the coefficient of x to the 4th is negative 280. So what they're saying is that negative 280, so when r is equal to some number, and in this case, they're talking about when r is equal to 3, right? Because when r is equal to 3, it would be x to the 4th. So they're saying the x to the 4th term is negative 280 x to the 4th. And so if we write that out, we can write out, well, in this case, now we already know that r is 3. And then x to the 4th, b to the 3rd. Okay, so basically we can, okay, x to the 4th, x to the 4th, we can equate the rest. So it would be negative 280 is equal to 7 over 3 b cubed. And then so from this we can kind of figure out what b cubed is. 7, n equals 7, b equals 3, it would be something like 7 times 6 times 5 times 4 divided by 4 factorial. 4, 3, 2, it would be equal to 35. So that would be negative 280 equals 35 b cubed So divide both sides by 35, and we get negative 280 divided by 35, and that would give us about 40, or is it negative 4? Or actually negative 8, something like that. Okay. So b cubed is equal to negative 8, so b would equal negative 2. Okay, that was kind of tricky. 4. Find the coefficient of, and it gives us two binomials here. Let's take the second one. So x to the 6th, y to the 3rd. So that would mean that r is equal to 3 and n is equal to 6. Right? Right, because n is equal to 6, we get it from there. R is equal to the 3rd because the b term will be y cubed. Okay, so we have a equals 2x squared, b equals negative 3y. Okay, and so if we were going to write the general term for this, we would write a to the n minus r, and then b to the r, right? And so n would be 6, r would be 3, a would be 2x squared to the n minus r, which would be 3. B would be negative 3y to the 3rd. Okay, and let's see if this works out. So this would be 8x to the 6th. Negative 3 cubed would be negative 27y cubed. And then we would have 6, 3, which would be something like 6 times 5 times 4 divided by 3. It'd be about 20. Okay, so you could do that on the calculator or by hand. N equals 6, r equals 3 would give us 20, I think. So that would give us 160 times negative 27 times x to the 6th y cubed. And so it says find the coefficient of, so the coefficient would be that. It would be negative 27 times 160. Let's see, 5. Find the constant term in the expansion of. Wow, that's kind of a tricky one because the constant term normally would be the last term, b to the 15th. But in this case, b is 2 over x squared. And a is equal to x. So the constant term would be somewhere in the middle because the a's and the b's would kind of have to cancel each other out. Oh, man. So the first challenge here is just to figure out what would be the constant term. So let's see. Remember that the general term looks like this, nr, and then we have a to the 15th minus r, and then we have b to the r. And then we're going to erase a because actually it's x. And then we're going to erase b because it's actually 2 over x squared. Now what does r have to be so that the x perfectly cancels out with the x squared? Let's see. If r was kind of in the middle, like 7, what would it be? 15 minus 7, which would be 8, x to the 8th. X squared to the 8th in the bottom. Now that would be wrong, but I'm just going to show you how it. If r is 7, it would be x to the 8th, and on the bottom we would have x to the 14th. So we can see that r is going to be too big if it was 7. So let's make r a little bit smaller. Let's try r equals 5 or something like that. Okay, so if r is 5, then it would be x to the 10th on top, and then it would be x to the 10th on the bottom. So r is 5. Okay? So we're going to put in r is 5, and then so n is 15, r is 5, and then it would be x to the 15 minus 5, so the x to the 10th, times 2x squared to the 5th. Okay. And then that would be the x to the 10th is going to cancel out with the x squared to the 5th on the bottom. 2 to the 5th is going to be here. So it'll be just the constant term would be 15, n equals 15, r equals 5. And then you'd multiply that times 2 to the 5th, which is 32. Okay? So 15 over 5, just remember that's 15 factorial over 10 factorial, 5 factorial, and then you multiply that times 32. Okay, so that'll give you the answer for that. Okay, first it asks us to do the first 6 rows of Pascal's triangle. Then it asks us to add up all the numbers, all the coefficients in each row of Pascal's triangle. I guess it shouldn't surprise us that it gives us numbers that double, because we kind of double every number the way we find Pascal's triangle. But copy and find the sum of the numbers in. We found all the sums. Copy and complete the sum of the numbers in row n of Pascal's triangle is, and we could say that like in row 1 it's 1, in row 2 it's 2, in row 3 it's 4, in row 4 it's 8. So maybe we could say that it's 2 to the n minus 1. Show that 1 plus x to the nth is equal to So what they're saying here is just that, like, if a is equal to 1 and b is equal to x, then when you expand the binomial, it looks like this, right? And then if x is equal to 1, then all your x's would just, disappear, because it's just 1 times 1 times 1 times 1, etc. And then you could say that that's equal to 1 plus 1 to the nth, which is 2 to the nth. Okay? So that's how you get this formula here. Let's do b, because it seems to be the more complicated one here. What we're going to do is we're just going to expand this out and see which terms are going to have x to the 6th in them. So remember, a here is 3x, and b is equal to 1, and is equal to 9. So if we expanded this out, we would have a bunch of terms. The first one would be that one, of course. The next one would be that one. And since b is just 1, we don't need to write the b terms. And then eventually we would get to the one that's close to x to the 6th. So let's do, like, for example, we'll do the x to the 6th term. So that would be 3x to the 6th. 3x to the 6th, and then the coefficient would be 9,3, right? Because the 6 comes from n minus r, so 9 minus 3. And then the next term would be 9,4, 3x to the 5th. And we're going to need both of those. And the reason why is because, like, in the end, they want to know what is the x to the 6th term. But since you're multiplying this polynomial by 2 and you're multiplying it by negative x, there's 2 terms which contribute to the x to the 6th term. And one of the terms is going to be 2 times this term. That's going to give you x to the 6th, of course, right? And then the other term is going to be the negative x times this term. Because here you have x to the fifth, and when you multiply it times negative x, you also get x to the sixth. Okay? So both of these terms affect the x to the sixth coefficient. So I'm going to write the pink term first. So it would be 3 to the fifth, x to the fifth, but you would multiply it times negative x also. And then the other term, the orange term, would be 9, 3 to the sixth times 2 times x to the sixth. Okay? So the coefficient would be both of these things added together. Like the orange term would be 9, 3 to the sixth times 2. And the pink term would be 9, 4, 3 to the fifth, and that it would be x to the sixth, and it would be a negative because negative x to the sixth. Okay, so the coefficient would be this mess here, and that's all times x to the sixth. Okay, so to simplify that, you could do it by hand, but on a problem like this, probably they're going to ask you, or they're going to tell you that you can use the calculator. Okay? Let's see, go to the next one. Consider the expression x squared y minus 2y squared to the sixth. Please excuse that line there, it's just the mouse, okay? Find the term in which x and y are raised to the same power. Probably what you do here is you would expand this out, and you would have your Pascal's triangle, and then you would identify A as being x squared y, and you would identify B as being negative 2y squared, and then you would complete your expansion until you get to the term that has the same number of power for x and y, which is what they asked for. They raised to the same power for x and y. So this would be x squared y to the fifth times negative 2y squared. 15 would be x squared y to the fourth times negative 2y squared squared. 20x squared to the y third, negative 2y squared to the third. Are we getting close here? 15 x squared y to the second, negative 2y squared to the fourth. Okay, I think we probably found it somewhere here, so let's try to simplify this. So this would be x to the 12th, y to the 6th. Those are not the same. This would be x to the 10th, y to the 5th, times negative 2y squared. So no, that doesn't, that would be y to the 7th, so that's not quite it either. This would be x to the 8th, y to the 4th, negative 2y to the 4th. Hey, there it is, right? Because we have, this would be y to the 8th, x to the 8th. So the term that we wanted was this one. So all, you know, this is just a fancy problem where you just expand it, and then after you get all the correct terms, then you figure out the exact term that they were looking for here. Okay. So 9. The third term of 1 plus x to the nth is 36x squared. Find the fourth term. Okay. So this is a little tricky because they don't tell us what the degree of the equation is. They only tell us that the third term is 36x squared. Um, we do know some things, right? Because we do know that the r value is 2, right? Because here we have a equals 1, we have b equals x, and so b to the, it's b squared here, or x squared, so that means r is 2. So 36 is actually equal to n over 2, or n2. And so we could figure out, what makes this true. When does that equal 36? It would actually be n equals 9, because 9 factorial divided by 7 factorial is equal to 36. Okay, so we just found out then that n is 9 and r is 2, and so the fourth term we could find by finding this, and then this would be multiplied times x to the third. Okay. All right. What about b? If 1 plus kx to the nth is equal to this expansion, find the values of k and n. So again, they don't give us the degree, but from the terms we can figure out. Let's see. A is equal to 1. B is equal to kx, and we don't know. So let's say for r equals 1, we got n1 times a is 1, b is kx to the first is equal to negative 12x. So n1, which is just equal to n1 is equal to n. So nkx is equal to negative 12x. We know that n is an integer, and if n is an integer and negative 12 is an integer, then k also has to be an integer. So like n could be 12, k could be negative 1. N could be 4, could be 6, I guess. K could be negative 2. N could be 4, k could be negative 3. N could be 3, whoops, not negative 3, it could be 3. K could be negative 4, N could be 2, k could be negative 6. Okay, so those are pretty much the possibilities. And we know it can't be a really small one because, like, look, we got at least 4 terms. So if we have at least 4 terms, it can't be that one, it can't be that one. Now we just have 3 possibilities, and we could just try these 3 possibilities. Like, we could say, okay, n equals 4, k equals negative 3, and then see what you get for the third term in this case, right? With n equals 4, k equals negative 3, you would be able to get negative 12x for the second term, but what would be the third term? So I'll show you how that works. So you go 1 plus, and then k is negative 3, so we say 1 minus 3x to the fourth. And so we'll say, okay, the first term is going to be 1. The second term is going to be, well, since it's to the fourth, it would be 4 times 1 times negative 3x, and the 1 would be to the third, or to the third. And so that would give us negative 12x, right? But what would the next term be? The next term would be 6, 1 squared, negative 3x squared. So that would give us, no, that wouldn't give us, right? It would give us like 54 or something. So no, it's not this one. So then we could try the next one, which would be 6 and negative 2. So it would be 1 minus 2x to the 6th. Does that work? So that would be 1 plus 6, 1 to the 6th, negative 2x to the first. And then what would the next term be? It would be 15, according to Pascal's triangle. 1 to the 5th, negative 2x to the, oops, this wasn't to the 6th, it's to the 5th, but it doesn't make any difference, right? And this is to the 4th. And this is to the 2nd. So this would give us negative 4, yeah, it would give us negative 60x squared. Yeah, so we got the right answer. So the combination would be this. It would be n equals 6, k equals negative 2. Okay? Last one. Find a if the coefficient x11 in the expansion of this is 15. So once again, we're just going to expand this. So a is equal to x squared. And don't get it confused with this a or this a. We'll say that that's the black a and this is the red a, okay? B equals 1 over ax. Okay, and that's the black a, okay? All right, and then, so what does the x to the 11th term look like? So that would be, so the first term would be x squared to the 10th, and we know that it's the 10th power, so the second one is going to be 10 x squared to the 9th, 1 over ax, and that's the black a, I'm sorry. And then the next term is going to be 45 x squared to the 8th, 1 over a to the x squared. Okay, and let's see if we have x to the 11th yet. The next term would be 120, according to Pascal's triangle. X squared to the 7th. I'm going to write it down here. 120 x to the 7th, or x squared to the 7th, 1 over a to the x to the 3rd. What about this one? Yeah, this will give us x to the 11th, right? Because if we simplify this, we'll get 120 x to the 14th, and then on the bottom we'd have x to the 3rd, and we'd have a to the 3rd. So this would simplify to x to the 11th, which is what they asked for. And so what's the coefficient? So if the coefficient is 15, then we're saying 120 divided by a cubed is equal to 15. So that means a cubed is equal to 120 divided by 15, which is the same as a cubed equals 8. So a equals 2. Okay, so when a is 2, then that all works out. That was a hard problem.